Today we are going to see about construction and working of three-phase alternators. Okay, three-phase alternators are nothing but three-phase generators which are being used to generate power to your houses, factories, and any applications which are present. Okay, first we will be seeing about the construction. After that, we will be seeing the working. Okay. This is the complete construction of a three-phase generator. Okay, here you will be seeing two main parts. Okay, one is the stator and another one is the rotor. Okay, the green color part is the stator. Okay, and this one is the rotor. Okay, here the spider represent the poles of the rotor. Okay, here you can see this is the stator frame, stator core, and these are the cage windings and end rings present, and here are the cage bars. Here you can see the exciter which are used to make the field winding to be magnetized, and here are the brushes which are being used to supply power into the rotor. Okay. Here are the stator terminals. Since it is a three-phase alternator, you will be having a three-phase connection out from the alternator. Okay. This is the stand where you can connect the rotor to the mechanical blimp, okay, where it cannot move. Okay, you can screw down the rotor, so screw down the stator. Okay. This is the main construction. Let us see one by one. Okay. This is the armature winding. Okay, the armature winding is made up of three phase. Okay, you will be having a three-phase winding. Okay, this winding is wound with 120-degree phase shift with each other. Okay, this winding is made up of 120-degree phase shift with each other. The windings are made up of copper. Okay, and these stationary cores are made up of silicon steel material. Okay, these three-phase winding has a star connection, will be wound in star connection. You may know what is star connection. The windings are wound in star connector. Okay. After that, you will be having four terminals. One is the R phase, one is the Y phase, and another one is the B phase. Next, you will be having the center point neutral. Okay, this point. You will be having four terminals out from the stationary stator winding of a three-phase alternator. Okay. This is common for all the alternators available. Okay. In single phase alternator, you will be having only one phase. Okay. But in recent days, in present days, there are no single phase alternators. We will be having only three-phase alternators because it is very economical and it is used to generate power. Okay. No one will generate power for a single phase. They will always generate power for three phase. So only three phase alternators are available. You cannot buy a single phase alternator, but you can do a single phase alternator, but it should be done manually by yourself. Okay. You can do only three phase alternators. Okay. This is the stationary stator core, and here you can see the windings. These windings are made up of copper, and it is wound with 120-degree phase shift. Okay. In the stator winding, you will be obtaining supply. Okay, which means the supply will be get as an output. Okay, the supply will be get as an output. The alternator will convert mechanical energy into electrical energy. Okay, you have to provide rotational energy, that is the mechanical energy as the input. Okay, you have to give mechanical energy as the input, and the synchronous generator will give you an output of electrical energy in watts. Okay, you have to supply the power in newtons. Okay, in mechanical energy, you have to supply the power in newtons, or torque. Okay, the rotational torque you should provide. Okay. The output will be in electrical energy, which is watts. Okay. So the current from the three phases, that is the R phase and Y phase, will be driven out from the alternator. Okay, this is the basics of stator winding in the alternator or stationary winding in the alternator. Okay, next we will be moving to the stator core. Okay, in stator core, this is the stator frame. Okay, this is the outer part is the stator frame, and here you can see the laminations. Okay, these are all the laminations which are present. Okay, the laminations are being used to reduce the eddy current losses. Okay, you know what is mean by eddy current loss, because we have seen these things in the earlier stage of the subject. So to avoid eddy current losses, the laminations are present. Okay, similarly, there are air ducts. Okay. These air ducts are being used for the cooling purpose of the stator winding. Okay, this is the stator core. You can see the stator outer core is being made up of cast steel, which is a very hard steel. It cannot be broken down. Okay. The inside material is made up of laminated steel. Okay, these steels having stampings and laminations to avoid eddy current losses. Okay, the outer core is also made up of iron. Okay, the strength of the outer core is very high. Next, we will be moving to the rotor. Okay, according to rotors present in the alternators, there are two types of rotors. Okay, one is salient pole rotor. We will be seeing this first. After that, we will be seeing the next rotor. Okay, in salient pole rotor, this one is the shaft. Okay, this one is the shaft. Okay, these are the poles, salient poles. Okay, these are the salient poles. These are the salient poles present. Okay. Here you can see the damper windings. These are the damper windings. Okay, and where are the field windings? Okay, in this figure, the field winding is not shown. Okay, the field windings will be present here. Okay, the windings will be present here. Okay, the windings will be connected in the wounded in the bar of the shaft rotor. Okay. You can see there will be connections between the windings. Okay, there will be connections between the windings and the output. That is, you have to supply DC supply as input. You have to connect one end of the supply to the positive terminal and other end to the negative terminal. So in stator, you are going to get a three-phase supply as output. Okay, you are going to get a AC supply as output. But in rotor, okay, in rotor, you have to provide a input supply which is DC. You should provide a DC supply as an input to the rotor. Okay. When you supply a DC to the rotor, the poles which are present here will get magnetized, and these poles, this is a pole, okay, this one is a pole, and this one is a pole, and this is a pole, and this is a pole, and this one is a pole. These poles get magnetized. Okay, this will become north, and this one will become south. Okay, this will become south, and this one become north, and similarly this one will become north, and this one will become south. Okay, so these magnetic poles are created when you supply a DC power into the field windings. Okay, this is the field windings. If you supply power, the field windings will be excited and the poles will become magnetized. Okay, when it becomes magnetized, the rotor act as a magnetized rotating flux which is rotating inside the stator. Okay, this is one type of rotor. There is another one type of rotor which is known as cylindrical rotor or non-salient rotor. Okay. This type is known as salient rotor, but this type is known as non-salient rotor or cylindrical rotor. Okay. The main difference of these two types of rotor are in salient pole rotors, there will be fixed amount of poles. In this rotor, we are having 1, 2, 3, 4, 5 and 6 poles. Okay, so the pole count in this rotor is 6. Okay, there are salient rotors of pole 4 and 8. Okay, not greater than 8 poles. Okay. There are only salient pole rotors which are from poles is equal to 2 to 4, 6 and 8. So this is a salient type of rotors. Okay. Here in cylindrical rotors, you are having several poles. Okay, this means this small end will act as a one pole. Okay, the next small end will act as another pole. Okay, and the next one will act as another pole. Okay, these rotors are made up of lamination. Okay, this one is made up of lamination, and it is we use silicon steel for laminating. Okay, there are several slots. You can see this one is a slot, this one is a slot, and this one is a slot. This is one is a slot. This one is a slot. Okay, there are several slots present in the cylindrical rotor. Okay, in the slot, you will be having the field winding. See, this one is the field windings. This field windings should be given supply. Okay, this field windings should be given supply with the help of a DC supply, which is given as a input. You have to connect the field winding positive terminal and the negative terminal to the DC supply. Once you provide the DC supply, this non-salient rotor will become magnet. Okay, here you can see the north-south poles of the non-salient rotor. Okay, next we will be seeing the salient rotor versus non-salient rotor. Here there are two types. One is salient rotor and another one is non-salient rotor. Okay, here you can see in salient rotor there are only 4 poles. Okay, but in non-salient rotor there are greater than 8 poles. Okay, so the main difference between the two types of rotors are these types of rotors are being used in windmills. Okay, windmills. Okay, and it is being used in hydro power plants. Okay, hydro power plants. Okay, but these types of rotors, which are non-salient and cylindrical rotors, are being used in steam generators. Okay, that is thermal power plants. Okay, steam power plants and the nuclear power plants. Okay, why this difference occurs here is because of its mechanical strength. Okay, since this type of rotor has 90-degree phase shift, if this rotor is rotated at a very higher speed, the bars which are present here gets damaged. But in non-salient rotor or cylindrical rotor, the form of the rotor is in cylindrical shape. So the speed of the rotor can be increased greater than 1500 rpm. So this is the basics. Okay, so this is the basic to use the speed. The deciding factor is the speed. So if you are using the motor in windmills, the rotation is very less. So you can use these type of salient pole rotors in windmill. But in steam engines or steam turbines and nuclear turbines, the rotating speed of the turbine is very high. You should use this type of rotor. Otherwise, the rotor will get damaged. So to find the speed required, you are having one formula. Okay, it is nothing but ns is equal to 120 f by p. Here In India, the speed of the alternator which is being rotated can be found. How? You know the frequency is 50 hertz. Okay. Consider the four-pole generator. Okay. Consider it is a four-pole generator. Then what happens here is you will get a value of 1500. See, you will get a value of 1500 rpm. Okay, but in United States you will be having a frequency of 60 hertz. Okay, if you have a frequency of 60 hertz, then you will be having a poles of 4. Then what should happen here is you should rotate the generator in the speed of 1800 rpm. So this is the difference in rotating speed created by the frequency. Okay, if you need 50 hertz frequency, you need to rotate the rotor in 1500. If you need the frequency of 60 hertz, you need to rotate the mechanical power should be 1800 rpm. Okay. Now, let us see how this machine works. Okay, how this machine works. Okay, first, here you are having the stator. Okay, here you are having the stator. In stator, you are having three windings. Okay, one, two, three. Sorry, one, two, three, and another one, four. Okay, which is R, Y, B, and neutral. Okay, from R you will be get the output, Y you will get the output, and B you will get the output, and similarly in neutral also. Okay, this supply is AC supply. Okay, this is the output of the alternator. Okay, what you should provide as a input. Okay, in rotor. Okay, this is for stator. For rotor there are fields. Okay, here you will see the field windings. Okay, in field windings you need to supply a input, that is the DC supply. Okay, you need to supply DC supply into the rotor. Okay, once you supply the DC, these fields get excited and converted into field windings, and the field fluxes will be generated over here. Okay, the field fluxes will be generated over here. Okay, this field fluxes should be rotated. How this is rotated? The shaft is present at the center of the rotor. By rotating the shaft with the help of a turbine, okay, with the help of a turbine, you can rotate the generator. Okay, this turbine may be a steam turbine or a wind turbine or a hydroelectric turbine. The turbine may be of any type. Okay, if you use a turbine to rotate the shaft of the rotor and you provide the DC supply, then this flux created in the rotor windings starts to cut the armature, that is the stator conductors, where the three-phase winding is present. At once, according to Faraday's law, when the stationary conductor is being cut by a magnetic field, at once an EMF is generated. This EMF is responsible to produce a current when a load is connected across the conductors. Okay, this is the R phase and this is the neutral and this is the node. Okay, connected to the points over here, then the current will flow into the load. And this is the basic principle of construction and working of a three-phase alternators. Okay, you can see in thermal power plants like Tuticorin or Neyveli, NLC, wherever, they will be using the alternators like this to produce power. Okay, the steam which is being used for production of mechanical energy is fetched from the waters available from the source. Okay, In TTPS, okay, in TTPS, this is thermal power station. You can see this one is the thermal power station. This is Thuthukudi thermal power station, TTPS. Okay. Okay, in TTPS, they will be using the water as Tamarabarani river water. Whereas in NLC, this is another one power plant. Okay, there are two power plants very close to each other. Okay, in Tuticorin, you can see this one is NLC power plant. In NLC power plant, they are using seawater. Okay, they will purify the seawater and use it for heating purpose, and they will generate steam, and they will give this to steam turbine and rotate the turbine. After that, the turbine will rotate the alternator shaft, and the power is being generated. Okay, uh, the inside of the power generating station will be like this. Okay, here you can see the alternator. This is the three-phase alternator, and this is the turbine. Okay, you can see this is the turbine, and the steam is being provided from the boiler. Okay, so this is the complete construction and the working principle of a thermal power plant where the synchronous generator is being used. Okay, thank you.